Hello and welcome to physics. Teacher Patrick here. We're going to look at internal resistance. You've watched the two videos that I've also connected. So this is the third video you're watching. Okay, you watched the first two YouTube links, and now I'm going to explain internal resistance to you guys. Okay, so let's go over to the visualizer. Okay, so guys, what is internal resistance? We've now seen that internal resistance is when the cell actually has its own resistance. Okay, and I always describe this as the cell is like a corrupted government. Okay, the cell has a EMF of 6 volts, but internally inside this, okay, there is some corruption happening, and the cell is eating away or stealing away some of the money that is, or energy that is supposed to go to the rest of the cell. And the rest of the cell only gets 5.8 volts. So 0.2 volts is then being used up by this internal resistance. Okay, and this is what we call the external resistance. Okay, so internal resistance is like a corrupted government. Okay, so the cell is corrupted, and what happens is as the cell gets older, the internal resistance gets bigger, up to a point where the cell uses so much voltage that basically no voltage is left for the external circuit, and then we would call it flat. The cell is flat. Okay, the battery is flat. Okay, so that's the idea of internal resistance. Okay, we have now looked at the video, and we've seen that this is basically Newton's Kirchhoff's second law, where the EMF is equal to the sum of the potential differences. So if we have our circuit, there's R, we have small r, and we have our internal resistance there. Okay, so here we have our EMF, we have IR, which is basically our the external voltage, or we call it the terminal potential difference, plus our internal resistance, or the voltage lost. Okay, so they discussed about a graph where we have the voltage, which is the terminal potential voltage over the current. If we rearrange that formula, we say E is V plus IR. Okay, and if we rearrange that, we get that V is, I'm going to swap it around, negative IR plus E. We could have seen E minus IR, and then we rearrange it this way. So this just helps us to see the straight line graph. Y is equal to mx plus c. The EMF is our y-intercept. Okay, the negative gradient, or the gradient, is the negative of the internal resistance. So since this line is negative, if I plot a negative value in there, and the negative times a negative gives me a positive internal resistance. So the gradient of this graph gives me the internal resistance, and the y-intercept gives us the EMF, and that's why we do the practical to get these two values. Okay, so that is basically just the concept behind the graph. And now the question is, how does this link up to what I've taught you guys before with regards to circuits? Okay, and we have now our internal resistance. Let's make the internal one color. Okay, and then we have our external resistance, or resistors, R1, R2. Okay, now what I've previously taught you guys, that we have to look at the values R1, R2, and R total. So if this was a normal circuit, we would have 1, 2 resistors and the cell at the top, and we would say R, V, and I. But now what changes, guys, is that what we used to call R total is just the external circuit. Then we have an internal resistance, and now the total resistance is the sum of the external plus the internal resistor over there, small r. Okay, so we have another onion layer. Okay, remember we said it's layers of an onion. Okay, so It's also in series. That's also in series. The external circuit, whatever the external is, if the external is a parallel circuit, the sum of the parallel becomes the external. If it's a mixed circuit, the total, what we used to call the total resistance now, is the total external, and then we add the internal to get to the total. So what this makes use, or this is useful for the following. Here we can get the EMF. Here the voltage for this one is the terminal potential difference, and this is the lost volts that is used up by the corrupted internal resistor. So just to give you some background and basically see how it fits in, all the rules and stuff still apply. It's basically just a next level or a next layer of the circuit. Okay, so I hope you guys are okay, understand this, and if you've got any questions, please let me know. We'll discuss this in our next lesson. Have a nice day.